Imagine if you could simply open up an architectural model, do your analysis, and then print out the resulting engineering drawings using just one file. You just click File Open, add your input, and then File Print. Think how much time could be saved compared to all the different programs and inputs that you have to use today. Working with others would be so much easier as well, and you could test so many more options for the best solution. Unfortunately, this isn't the current reality, although is there any reason that the software can't do this? In this video, I look at some current approaches to sharing engineering information and how useful they are. Examples included the IFC format, Rhino.Inside.Revit, Speckle, and some others. So why is it so hard? The basic problem is that each piece of software uses a different format than every other piece of software. It's an interoperability problem, and unfortunately it's been around ever since software was developed for engineers and architects. So why don't we use a standard format for all engineering information? For one thing, there isn't much incentive because there's no money to be made. In fact, there's an opposite incentive from a software company's perspective. If they allow anyone to transfer the information, then anyone can switch to using another program. It's far better if engineers and architects have to pay every year to keep working in a format that's only compatible with their software. Another reason though is that it's pretty hard to do. It should be pointed out that there's been many attempts at creating an open standard over the years. For much of this time, the solution has been seen as a file type, but today there are also some other new techniques available which I'll talk about. So, as I said, for many people, the answer to sharing engineering information means a file type that can be opened by every program that you use. The most basic use of this technique is the DWG format, for engineers especially. It can carry primitive geometry such as beam center lines, but it can't really carry other information like member sizes or loads or anything like that. It gets used if there's no better alternative, and it still takes a lot of time getting the other information into each of the different programs. That file type approach has a long history, however. An early attempt at a universal format is IGES, which has been around since 1976, so this is not a new problem. It was developed by the US Air Force as a vendor-neutral file format to allow the digital exchange of information among computer-aided design or CAD systems. This file type was originally based on punch cards, and due to a number of disadvantages, it was eventually mostly replaced with the development of the more modern STEP format, STEP format. STEP took a more advanced text-based description approach, and it's defined by ISO 10303, the standard. While this proved more useful than IGES, it's still rather complex. It can't support textures or other information, and it isn't an open free standard. So the most current attempt at a universal file type using ideas from STEP is IFC, or Industry Foundation Classes. And you've probably heard or seen this as an option in the file menu of many programs. It's probably the most popular and useful file format for engineering information today. Unlike other formats, it's open for use by anyone, and it supports many different types of engineering objects. A majority of software programs also support it in some way, although some are better than others at this. Despite these many advantages though, the IFC format can be a little bit controversial. If you read other people's opinions online, it seems to be something that is either loved or hated. It does have a reputation for losing parts of models or other information in the transfer process, and it's considered to be fairly complex to use. There's an excellent article on the pros and cons of IFC, because I'm not an expert, and I'll put a link in the description below. It should be remembered though that all of these standard file type approaches, including IFC, are actually more of a transfer file rather than a working file. So obviously the imported items that come from IFC are usually sort of second-class citizens within the program, and they can be static. So it's not normally possible, for example, to open an IFC file and just start editing and using members directly in Revit, for example. So apart from files, what other types of transfer options are available though? A file isn't the only way to transfer information these days, as data can now be streamed locally on your computer or on the internet. This approach is being used by projects such as Speckle, where the data from one program is streamed to a database on the internet and then can be written to another program from that stream. For this to work, both programs require plugins which allow the transfer, and you have to have an online account, obviously. This does seem like a promising approach if all the various programs and plugins are maintained and work well. Many of these solutions are currently a work in progress, as it's early days, but there might be a good option for some workflows. Another new way being used to transfer engineering information is by writing it to a program directly by accessing an API. Not all programs have this feature, but the larger ones such as Revit and Rhino do. This technique allows software such as Rhino.Inside.Revit, for example, to directly control elements inside a host program, in this case obviously Revit, so that no file or transfer stream is even required at all. So whenever you draw an item in one program, it will directly appear straight into the other program. And this is useful with parametrics and other things where you can script things like that. There's currently a lot of excitement around Rhino.Inside.Revit, Rhino.Inside.Revit, I should say, in particular. However, you shouldn't forget that this solution only helps with two specific programs. It's not currently any use for any of the other programs an engineer or architect typically uses. So in summary, there doesn't seem to be a unified way to store or manipulate engineering information that works across the industry. Because of the lack of incentives, a universal solution to this problem might be far off into the future, or we have to face the fact that it might never be developed at all. It seems therefore that the best way to deal with this situation is to take a practical approach. You can use the technologies and techniques available, which I've discussed above previously, where we can, but we can only go so far as the current software allows. One thing we can do without the software companies or other developers inventing a unified solution is to use the existing native formats where possible. There are online conversion services, such as one that Structured Parametrics provides, which will convert most structural engineering data to all of the different formats that the different programs require. This offers a quick way to get working on a project without all the complexity that I've been discussing here. At the end of the day, it's up to the designer to decide which techniques, if any, will provide the fastest, most reliable and easiest workflow for their project. Obviously, for a very small project, you might just consider working as you've always done. But for larger projects, it's probably worth thinking about a way to transfer information that's already been created as a model into another model, instead of recreating model after model after model and updating as the project progresses. I've got a summary of the things discussed here as a table, and you can also find it in a blog post that I've done, which I'll put a link to below. But what do you think? Is there a conversion method that you're using at the moment that works well? Do you think we'll ever come up with a universal file format? Or do you think it's just not worth bothering with and we just have to put up with the slow method of working that we've always done? Let me know in the comments below, and I'll respond where I can. Thanks for watching this Structured Parametrics video. Leave a like or subscribe if you found this useful, and we'll see you in the next one.